So we've established this relationship that relates the angle from the sources, from a point between the two sources out to a point on a nodal line, preferably a long way away so that awkward not right angle triangles don't enter into the problem. So this is the formula that we've come up with. Now, we are going to look at a slightly different relationship, and then we're going to bring these together into one formula. So we are interested in looking right across the pond, straight across from between these 2 point sources to a point that's straight across the pond. We're actually interested in how far this distance is from the center to the first nodal line. And we're going to symbolize it as x sub 1. Okay, so if we looked right out from the center, our first nodal line is a distance x sub 1 away from that. The path length here is L, so once again we're sort of simplifying things a little bit. We're saying that this is the path length here. Remember that we said this was the angle down in this little triangle, theta. If you remember your grade 9 math, this angle is actually the same as this angle. Okay? You look unconvinced out there. Okay, so this is actually the exact same angle, this theta right here. All right, ready? We're about to do something miraculous. So you notice that L is the hypotenuse. X1, in other words, the distance from the center out to a point on that first fringe, is opposite the angle. This is opposite over hypotenuse, and so the sine of theta is equal to the distance from the center line to the point, which is x1, over the distance that the wave has traveled, L, capital L. So this is for the first angle. In general, the angle to the nth fringe is equal to x sub n over L, where x sub n is the distance from the center line to the nth fringe. So you notice that there's sine theta n there, there's sine theta n there. They're actually the same thing. So x sub n over L is equal to n minus 1/2 lambda, n minus 1/2 lambda over d. And I should have put an n minus 1/2 lambda right there. Okay, so n minus 1/2 lambda, that's going to give us a half a wavelength when n is 1. When n is 2, it's going to give us 1.5 wavelengths, or 3/2 of a wavelength. When n is 3, it's going to give us 5/2 of a wavelength. So here is the final big formula.